Hello, question number 19. It reads, a particle of mass m and charge q is projected with a velocity v0 in a viscous medium where a uniform and constant magnetic field of induction B exists everywhere in the direction perpendicular to the direction of projection of the particle. Further, it says the force of viscous drag on the particle is given by this law, where B is a positive constant and V is the instantaneous velocity of the particle. Find distance traveled by the particle during a time interval from the instant of the projection until velocity turns by 2 pi radians. So when the velocity vector turns by 2 pi radians, till then, starting from the beginning, we need to find how much the distance the particle traveled. So we will consider this solution, and let me explain how we are getting the answer. Let's say this is the int equal to 0, the initial situation, and the particle is being projected, let's say, in positive x direction, and magnetic field is into the screen. We know if the charge is positive, then v cross B force is going to act in this direction. So this force is going to change the direction of velocity. We know this magnetic force is always perpendicular to the velocity, so it won't be able to change the magnitude of velocity. It's always perpendicular to the velocity, so it changes the direction only. So it will be keep on changing the direction, and but we know there is a drag force as well acting. So this drag force is going to reduce the speed at any instant, which is, let's say, t time. This is the particle, let's say, and this is the velocity. That means the speed is now v. Magnetic force is going to be perpendicular to the velocity, and drag force is going to be opposite to this velocity. Now this drag force is reducing the speed, so the speed is decreasing. Since the speed is decreasing, so this won't follow a complete circle, so it will follow a curved path, that is a circle of reducing radius, because r is equal to mv upon qb at any instant. So we use r is equal to mv upon qb, then we'll find m qb, they are constant number, and since speed is decreasing, hence radius has to decrease, so it will be moving in smaller circle, or that means circle will get smaller in radii. So some sort of this path it is going to follow. Now till what we need to consider this, we need to consider when the velocity comes in the same direction to the initial velocity, so that it turns 2 pi radian, or you can say 360 degree. So this is the final condition we are considering. This is t equal to 0, and we need to measure the distance, this distance traveled. Now you see, it's a complex story because the path of this particle is complicated, and we know the distance is the actual path length that we need to find out. So what we can say, we can solve in terms of scalar quantities like speed, distance, and time. Now we know this speed is going to be reduced by this drag force. So rate of decrease of speed, if we need to find, we can call it as a tangential retardation as well. So this dv by dt is going to be f by m, is going to be like minus bv divided by m, where minus sign is going to say it's decreasing, and the rate of decrease is directly proportional to the speed. That means when the speed is more initially, for example, then you'll find decrease will also be faster. As the speed decreases, then the rate of decrease also decreases. That's what we can say. Now using this differential equation, we can solve this, and we can find the velocity as a function of time maybe. So we can bring this velocity this side and dt maybe this side. So it's going to be like dv by v is equal to minus b by m into dt. Then we can go for integration from initial values to some general values. Initial time was 0, velocity was v0. In magnitude, we are writing the magnitude of velocity, or you can call instantaneous speed. At any time t, speed becomes v. Now in left hand side is dx upon x type integration, that comes to ln x. And when we put the upper limit v and lower limit v0, then it's going to be like ln v minus ln v0. And we know properties of ln, it turned out to be ln v upon v0. So if you feel like steps have been jumped, you can fill the steps. And then this is going to be like minus b by m, and this integration is going to be t. From here we can bring this ln this side, so exponential and v becomes v naught e raised to power minus bt by m. That means this decrease in the velocity is going to be exponential. So it's exponential decrease over the time that we got over here. Now since this is a speed, and we know speed can always be written as ds by dt, the rate of change of distance. So we can replace this v as a ds by dt. So this is ds by dt is equal to this number. Then again we can bring this dt this side and separating variables. So ds is going to be like this number into dt. And then we can integrate both sides from initial values to final values this time. Now we need to decide what the final values are. Initially distance was covered 0 and the time was 0. Finally distance, let's say s, that we are looking for, and what will be the final time? Let's see. Now it completes one round. One round means what? It turns by 2 pi radians velocity vector. So we know since r is equal to mv upon qb, r is changing, v is changing, but v by r is equal to q by b, which is q constant, b constant, m constant. That means this is a constant number. That means v is reducing, r is reducing in such a manner that v by r remains constant. And by the way, we know this is also equal to omega instantaneously. That means omega remains constant. That means its time period of rotation remains constant. And we know time period of rotation is going to be written as t is equal to 2 pi m by qv. We could also set from here itself that this time period of rotation is independent of speed. Hence, this remains the same constant. So when velocity vector turns by 2 pi radian, it must be taking one time period, or you can say t time, capital T time. So limit will include, final limit is going to be capital T. Now then after its simple calculation, this has become distance, and from here v naught is outside and e raised to power something. Integration comes out to e raised to power that thing, and dividing by the coefficient of variable. So minus b by m is a coefficient, we need to divide by that and put the limit from 0 to t. Then after we will find this minus sign can be absorbed by switching the or exchanging the limits. So e raised this t can be put 0 first. So e raised to power 0, then in place of small t we can write capital T, and this outside we will get m v naught by b. Now capital T is this 2 pi m upon qb. So from here t by m can be borrowed, so by placing this is going to be like twice pi upon qb. So ultimately it will become s is equal to mv naught by v, which is outside 1 because e raised to power 0, minus e raised to power minus, and b was there, small b already. In place of capital T by m we can write twice pi upon qb, so it becomes minus twice pi b divided by qb. So this is the distance traveled by the particle till the condition given in the question. And we got to know this actual path length without knowing this path equation. So that's a good deal. So that's final answer. Thank you.